All right, we are going to go through section 8.2. So what we're going to do is kind of analyze data a little bit differently, not using necessarily a graph this time, but instead we're going to be doing some calculations. So an introduction would be just talking about the fact that we're talking about these numerical characteristics of graphs now, which is what we call statistics. So one statistic that describes the center of the data is called the measure of central tendency, which is something that you guys are probably used to doing, like calculating the mean, for example, would be a measure of central tendency. The median would also be. So something a little bit different with this is that your notation for mean, if we're talking about data set, if I say a set of values, my whole chunk of data is going to be called the letter X. If you draw the little bar over the top of it, we call that X bar. And what that means you're doing is calculating the mean of all of the numbers in that X. So if I give you a bunch of test scores or something, I would say X represents all of my test scores. But if I throw the little bar over it and I say X bar, I'm saying basically what is the average test score. Okay, so here's just some fancy schmancy notation. This symbol right here is a Greek letter. It stands for a word called sigma, and what this actually means is sum. So what you're doing in order to calculate your mean, which again, you guys have seen this formula before, in order to calculate a mean, you are taking the sum of all of your X values divided by the number of terms. So let's say I take 5, 10, 9, 7, and 5, and I wanted to find the average. You would add up all the terms and divide by how many there are. So since there are 5 terms, that's your n value. Your sum of all these on the top, you would just add them all together, divide by 5, and you get a mean of this. Again, we would say that this is X bar, and X bar would be 7.2. So what we're going to do is go to the graphing calculator actually, and I'll teach you guys how to get a mean, median, all this stuff. If we were to do this by hand, I would have you guys take 13 plus 4 plus 11 plus 7, blah, 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 blah. And then you would divide by the fact that there are 20 terms. You would take the sum of all these and then divide by 20. So we're going to go to the calculator, and I'll show you how we're going to put some numbers in here. So what you guys are going to do is get out your graphing calculator, and you are going to go to Stat, and you're going to go to Edit. And what I'm going to do, again, if you guys have numbers in here, let's pretend you have like an 8 in here, and you want to get rid of that, again, you would go to the top where it says L1, you hit clear, and then the down arrow will take you down here and it'll clear out all your numbers. So what I'm going to do is go down the list and enter all of these values in. Again, in order to get here, we went to Stat and then Edit, which is something that we had done before. Blah, 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 and blah. Okay. So I have 20 data points in here. Notice my cursor says that I'm on my 21st slot, which means I have 20 numbers above me. So all my 20 data points are in. If we want to do some calculations, this is like the uber cool part. You go to Stat and then over to Calculate. What this stands for is one variable statistics. So we're only talking about the number of sugar, the grams of sugar changing here. So we're going to be calculating our one variable statistics off that. We're referring to the list that we stored everything in was in L1. If you went back to Stat and Edit, all your values should be under that first list, which is L1. I'm going to go down to Calculate, hit Enter, and I get all of these values. It's a lot of good information here. The first thing you see here is X bar, so that's your mean. Your mean is 7.85. Your sum of all the X values, so if you did add all these up by hand, you would get 157. Skip these next few things, look at where it says n equals 20, that's talking about your number of terms, and then we get into the stuff that would help us with the box and whisker plot. Here's your minimum, here's your maximum, there's your median, and then it has your your first and third quartiles on there. So the calculator is a really good way to organize your data from least to greatest without even doing it by hand, and it calculates all of those statistics for you. So I'm going to take down some of these notes then over here. I'm going to go to question number 2. We're going to take these down. So again, my mean was 7.85. We had delta X, or the sum of the X values was 157, which means when we added up all of your X values, you got 157. And there was a total of 20 values. So again, this thing represents your arithmetic mean. This was your sum of amounts of sugar. I'll just write grams of sugar. And this was the number of cereals. So we took 20 data points and we averaged them together to get the 7.85. This says determine the median amount. So what I'm actually going to do for this part is write down my 5 values for the box and whisker. Actually, you know what? Let's just take down the one. Let's take down the median for now. The median is 7. And so I'm going to write that down. Median is 7. And I also want to talk about the mean, which was the 7.85, because we're going to talk about how the median is actually less than the mean. And there's going to be a reason for that. It says interpret the median in terms of the problem situation. Again, this is talking about your average grams of sugar. If we're talking about the 7, that means 50% of your data is greater than 7 grams. And 50% of your data is less than 7 grams of sugar. Because what we talked about in the box and whisker plot is wherever that median is, half your data was on one side and half of your data was on the other side of it. And that's what made up the, like from Q1 to Q3 is another 20, is another like 50% chunk. There's a lot of all these different percentages from box and whisker plots. What I want to do is take a look at number 5 where it says this was the box and whisker plot that we had constructed in one of our previous lessons. We're going to locate where the mean and the medians are. So I'm going to locate that the median is at 7. So I'm going to put a little bar here, say that this is the median. And then underneath this, it says 7.85. So closer to about this side is where my mean is. Okay, so notice that our data itself was skewed to the right. So a lot of our data was on this left-hand side of the graph, and that's why we said in the last lesson that this was skewed right. So a couple things to identify here. We have a skewed right graph. Our median is on the left side of the mean, and notice that the majority of your data is on the lower end of this sugar scale here. So more of the cereals contained a lower amount of sugar. Now this is saying compare the mean and the median, which I did. I would say, because it says which measure best represents the data set, I would choose the median only because it's going to be really focusing on where this peak of our data is and how it's, again, it's that 50-50 split, that 50% of your data is on one side of it, 50% on the other side. It's a good number to go off of. Because what we're about to do then for number 7 is remove the value of 22. So what that's going to do then is take this maximum value and really shift it down, because the next highest value is at 13. So I'm going to go back to my calculator. I'm going to go to Stat, go to Edit, and I'm going to find where 22 is, and we're going to get rid of that data point just to see what it does to our values that we calculated. So I'm going to go to 22. I'm going to hit this delete button. And now all of a sudden my 20 data points becomes 19. I'm going to go to Stat, go over to Calc, and we're going to calculate our one variable statistics again, and it's going to recalculate everything for us. So notice that the mean went down from 7.8. Now the mean went down to 7.1, which was closer to where that median value was. We have a total sum of 135, and that's because we took away 22 of those grams of sugar when we deleted that 22 data point. And then my number of terms went down to 19. As far as your box and whisker plot goes, we're going to create one for this the new data points, taking away the 22. We're going to calculate using a minimum of 1, a maximum of 13, and a median of 7. So that's going to say, and you guys can do this directly above it, 4 would represent your first quartile. 10 is going to represent our third quartile. 7 is the median. And then 13 was your new maximum. If I go back to the calculator here, 13 was your max. It looks like 7 was your min. It looks like 1 was still your min, and then 7 was your median. So if I'm only looking at the graph in blue here, I'm going to answer a couple questions associated with it. It says, how does the removal of the value of 22 affect the distribution of the data set? So let's look at this graph right here where my cursor is. This graph looks like it was skewed to the right, If I remove 22 and I'm only looking at what's in blue here, this looks a lot more symmetrical. It looks like 50% of your data is on this left side, and it looks like it's almost the same size as the other side. Versus this one down here, remember 50% of your data is in where my cursor is here, and 50% would be in this big chunk to the right. So removing 22 is going to take that maximum down, and it's also going to carry your mean down as well. So yeah, it says did the mean and median change? Your median would stay the same as 7, but the mean is what changed. The mean went down from 7.8 to 7.1 because when you get rid of such a big number like 22 and you average all your values together, it's going to be a lot less. So that was really it for the first problem. On to the second one. We're going to compare heights of basketball players on two teams. We have a home team and a visiting team. And we're just looking at the top 10 players of each of the teams. So we're going to have 10 players on my left column and 10 players on my right column. And we are actually going to analyze these separately. And we're also going to make a dot plot for these. So what I'm going to do is pause this video actually. I'm going to create my dot plot and then I will resume it. So now that my dot plots are created, what I'm going to end up doing then is take a look at which way these data distributions look, if they're skewed left, skewed right, or symmetric. It looks like this one for the home team here on the left. This was the home, and this was the visitors. So it looks like the home team had a skewed left distribution, which means that more of your players were taller. And over here on the visiting side, it looked like the data was skewed right, which means the majority of your the majority of your players were shorter. So that's what it's talking about as far as these distributions for 2A. For 2B, it says based on the dot plots, predict whether the mean or the median would be greater for each data set. So this is the really big important thing that you take out of this lesson. Let's just pretend that my mean is somewhere around here. It wants to know if my median would be greater than this or less than this. So since the majority of your data points are on the right-hand side, your data is skewed left, your median would most likely be to the right of the mean. So your median would be greater than the mean. Versus if I had a plot like this, where the majority of your data points are in this section right here, you would expect your median to be less than the mean. And the reason for that, again, is because these higher numbers are going to try to bring up your average. But what your mean does is it identifies where that 50% cutoff is of your data. So 50% of your data will be on the left side, and then 50% of your data would be on the right side of the median. I made these lines really crappy. Actually, this average should be like somewhere over in this way. But either way, the mean, oops, this one will be shifted to the right. The mean would be, in this case, greater than the median, and over here, your mean would be less than your median. So it says verify our predictions by calculating the heights for each of these teams. So what I'm going to do is go to the graphing calculator, and we'll get practice putting these in again. I'm going to do them two different ways that I can calculate these. But I'll go back and just do these one at a time. So I'm going to go to my stat plot. And I'm just going to enter in all these scores again, or all the heights, 68, 66, 65, 70, 70, 71, and 71. And I'm going to go to stat. We're going over to calculate, and we are calculating the one variable statistics. So it looks like my mean is at 68.7. So I'm going to say that X bar is 68.7 inches, and that was for the home team, and I'll do the same thing for the away team, and we'll see what that one came out to. Oops. Okay, so I'm going to go back to stat, and we're going to go to edit, and I'm going to clear out all of these data points, and now we'll put these ones in. So 68. Okay, so 10 points there again. Go to stat, we're going over to calculate the one variable statistics, and that one is 68.5 inches. So both of these means came out pretty close. And what that means, on average, both teams have a player around 68.5 inches tall. But if you're looking at these distributions, it looks like this home team has on average a higher player just because of the way the median would be. The median would be larger since it's to the right, and your mean on this left side would be the larger one. So I think that the median would be a better measure of central tendency only because it's going to be closer to this peak of data. If you think about it, the mean would be right here. Like I said, it's about 68.5. So the mean is somewhere around here. But if we're looking at the number of data points, your median would be closer to about 70. And that's because it looks like the majority of your players are taller. Over here, if I go to about 68.5, it looks like some of your players are on this taller end. But again, the majority of your players are shorter than that mean, so your median might be a better way to go. Blah, blah, blah. I'm going to go on to this problem then, and we'll just have a little talk using that same concept that if we look at the way the data is distributed, we can estimate where our median would be as compared to the mean. So in this type of distribution, it's going to be skewed left. It looks like the peak of your data is on this right-hand side. So let's just pretend that your mean was somewhere around here. Well, since the majority of your data points are to the right-hand side, because your peak is to the right-hand side, that means that your median would most likely be greater than the mean if you were to calculate it. And you could go back, you could calculate from some of these data plots. You guys can calculate the mean and the median just to reassure, but usually that trend is going to carry on. So if the data is skewed to the left, your median would be greater than the mean. If your data were skewed right, your median would be less than the mean.